பெயர் சொல்லுமே
Dr. M.G.R. Educational and Research Institute, University, Madurai, Chennai.
Very pleasant morning to one and all to present here. First, I like to thank to our Dean Ma'am for giving the good opportunity. I would like to welcome you all for subject lecture organized by the Mechanical Department of Dr. M.G.R. Educational Research Institute and University. It gives me an immense pleasure to start this occasion by heartily welcome our university honorable founder and chancellor, honorable president sir, ACS Dr. Arun Kumar sir. Welcome you sir. Heartily welcome to VC madam Dr. Geeta Lakshmi. Welcome you ma'am. Respected registrar Dr. LB Paranivelu. Welcome you sir. Respected joint registrar Dr. V. Cyril Rash. Welcome you sir. And respected joint registrar E&S Dr. D.B. Jebraj sir. Welcome you sir. It is my very great pleasure to welcome our Dean ma'am. E&S Dr. N.S. Subhashri ma'am. Welcome you ma'am. And I would like to welcome to our first year BTech students. Welcome all of you, my dear participants. Welcome you. And you have to utilize this session. It's very useful to improve your knowledge. Welcome you ma'am. And I would like to welcome our chief guest Dr.Thangamani Bindhu ma'am. Now our Dean ma'am, N.S. Subhashri ma'am, giving the address.
Thank you, Ms. Devi.
Yes,
Hope I'm audible.
Yes, ma'am.
Yeah. Warm welcome and a good morning to one and all present for this occasion. Again, even though the welcome is given, I would like to thank our Honorable President for always motivating and guiding us, even through this pandemic, for having such good programs. I think, my dear students, you're all familiar that the subject lecture is a part of your curriculum. And whatever you are reading in the syllabus, the application-oriented part or the concept part is going to be delivered to students through our own faculty. So this is the main concept of subject lecture. So today you are going to witness one such subject lecture organized by Department of Mechanical Engineering attached to first year BTech. We have a very good staff with us, Dr. Thangamani Bindhu, who is very hardworking, and she is very innovative in giving so many videos to the students out of her own interest. So I thought her expertise should be used for even other students. So thank you, Bindhu ma'am, for accepting our invitation and being the chief guest today. And today you are going to, your students, you are going to have the subject lecture on development of lateral surfaces. The subject engineering graphics, even though many will say what is the use, right? But the engineering graphics is basically called as a language of engineers, right? So you're all engineers, so you should know the basics of engineering graphics. So that is going to be useful in your engineering and technology career, wherever you're going to go. So do not neglect any subjects that are offered to you, right? They are offered to you keeping in mind your the usefulness in future. Okay, so today one such lecture is going to be happening today. So please listen to it carefully and take home whatever the important points are discussed here. Also, you can put your queries in the chat box where madam will answer. So once again, I congratulate the department for initiating such a wonderful lecture. and appreciation for the department, the organizers, and the technical team. Once again, I welcome all of you for this subject lecture. Thank you.
Thank you, ma'am. Thank you very much. Now, I invite Mr. Chandar sir to give the guest lecture introduction.
Yeah, thank you, ma'am. Good
Yes,
morning,
sir.
all. I consider it's a great honor to welcome our guest lecturer, Dr. Thangamani Bindhu, in Civil Engineering Department. She has completed UG in SRM University and PG in Satyababa University. Later, she completed MBA in Madras University. She has completed PhD in St. Peter's University and she has done a research in the area of geopolymer concrete. So may I now invite the guest lecturer and a warm welcome. Warm welcome, Ben. It's welcome you all. So Dave, ma'am, it's over to you.
I like to invite the our guest today's guest Dr. Bindhu ma'am, Thangamani Bindhu ma'am, give the uh, subject lecture. Yes, ma'am, you can take over.
Good morning to one and all present here. First of all, I would like to thank our management and Dean ma'am for giving me this opportunity. Thank you, sir, and thank you, ma'am, for encouraging me to conduct this subject lecture. Thank you so much, ma'am. Dear students, I welcome you all for the subject lecture, and the subject is engineering graphics, and the topic which I have chosen is development of lateral surfaces. It is in the unit 3. Okay, the topic is from unit 3. Okay, now I'm going to share the PPT. The PPT will be the flow of the PPT will be like this. Okay, first part will be the definition. Second part will be the application of development of surfaces. Third part will
Hello,
be
ma'am.
various methods used
Ma'am,
for
good
the
morning. Sorry
development of
for the
surface of
interaction.
a solid. And last, it is about 4 problems, example problems. Okay, so the topic is development of surfaces, presented by Dr. M.K. Thangamani Bindhu, Associate Professor Civil, Dr. M.G.R. Educational and Research Institute, Chennai. Ma'am, second slide. What is development of surfaces? What is the need to understand the concept? Why we study about development of surfaces of a solid? Okay, the reason is any manufacturing. If you take mechanical engineering, manufacturing of the machines, manufacturing of products. Okay, any product manufacturing, the 3 things are very, very important that should be avoided. What are the 3 things? Loss of time, loss of material wastage, and loss of money. Okay, so we have to think about this and we have to design the product. Okay, so for designing a product, example, if you, now many are using mobile phones. Okay, for mobile phone, the flip covers we are using. Okay, the example I'm telling why we are in need of study of development of surfaces. Okay, the flip cover for a mobile phone. Okay, only if you understand the size, the shape. Okay, and the development of the surfaces of a solid, that is the development size, you will be able to design the product. Otherwise, it will end up in the loss of time, loss of manpower, loss of material, etc., etc. So in engineering application, it's very, very important to understand the shape, okay, and the development of the solid. Okay, so development of lateral surfaces of a solid, the definition, it means the unrolling or unfolding of all surfaces of the solid object on a plane. So here the reference plane we take, it is horizontal plane and vertical plane. Okay, that is the object, it will be in the space, it should be brought to the paper. Only if it is in the paper, it will be is brought to the paper, we'll be understanding the dimensions. It is very, very important to understand the size dimensions. Okay, so here the plane is horizontal plane and vertical plane. Okay, so what is lateral surface of a solid? The definition is the layout of only the sides of the solid, that is
Ma'am, Bindhu ma'am,
rectangular
can you hear
side
me?
or
Sorry for the
triangular side.
interaction,
Okay,
ma'am.
the side of the solid or object
Ma'am,
without its top of hello,
ma'am, Saravanan ma'am, your
சொல்லுங்க
voice
சார்.
breaking, ma'am.
இப்போ சார்,
Yeah, விட்டு
its
விட்டு கேக்குது
top or
கொஞ்சம்.
bottom face is called the lateral surface. Now sir, next slide ma'am. Yes, the engineering applications. Okay, so metal sheet work. Okay, so actually you might have studied this in workshop. Okay, in workshop metal sheet. Okay, you might have the I seen the example of making tray. Okay, tray, that is sheet metal work. Okay, in sheet metal work, development of surfaces plays a vital role, enabling a mechanic to cut paper size of the sheet. Okay, no wastage is allowed. Okay, so plate from the development and then to fold at proper places to form the required object. Okay, so here it's very, very important that we have to take into consideration the loss of material waste. Okay, so it will in turn directs to the loss of money. Okay, so it's very, very important to understand the shape. Okay, next the examples. Okay, where it is really used for boilers, metal boxes, buckets, bins, packing boxes, chimneys, pans, tray. Okay, so if you have a good knowledge about development of surfaces, packing boxes and all, it will be a perfect box. Okay, next slide ma'am. Okay, what are the various methods we follow for the development of lateral surfaces of solids? Are two methods, mainly two methods. There are four methods, but in our syllabus, two main methods are we are following. Okay, so first one is parallel line development. First method which we follow for development of lateral surfaces of solid, the first method is parallel line method. Okay, so I'll tell you about what is parallel line method. First point is used for developing cubes, prisms, cylinders. Okay, so this is a main point. Okay, parallel line development we are using for developing cubes, prisms, and cylinders, in which all the edges, generators of lateral surfaces are parallel to each other. This is the main point you have to understand. Parallel line method, we are using it for developing cubes, prisms, and cylinders. Okay, next, how we are going to follow that method is it's simple. Stretching out the lines, top baseline and bottom baseline. I'm going to explain one problem also, example problem. Just understand what is parallel line development. Okay, stretch out lines, we call it as stretch out lines. Okay, in this method, two parallel lines separated by a distance equal to the height of the solid are drawn by the side of its front view. Okay, so second point, important point in parallel line method. First point is it is used for the development of cubes, prisms, cylinders. Second point, it is a stretch out lines. Okay, you have to stretch out the lines, parallel lines, two parallel lines. Okay, next point is these two lines are known as stretch out lines, having the length equal to the perimeter of the solid. Okay, next point is prism and cylinder roll out into rectangular, stretching outs are called parallel line method. Okay, so first method, parallel line method, mainly used for developing cubes, prisms, and cylinders, and we follow stretch out lines. Next method, next slide, ma'am. Yeah, here you can see the development of cube. Right side, first one, it is development of a cube. For cube, all the sides are square. Okay, and four sides, top base, bottom base. Below that, you can see square. It's a square prism. Okay, square prism. For square prism, the lateral surfaces is a rectangle. Okay, lateral surface rectangle. Next, at the bottom, you can see triangular prism. Okay, development of a triangular prism. That is in right side. Left side, you can see the development of a cylinder. Okay, so development of a cylinder is just a triangle inside generators. Okay, so below that, it is a development of a hexagonal prism. Okay, only the top and bottom base will give you the true shape. See here, totally 6 rectangular faces and 2 true shape, top base and bottom base. I'm talking about hexagonal prism. Okay, so this is an example for various cubes, prisms, okay, and cylinder. Next slide, ma'am. Next slide, ma'am. Yeah, the second method. Okay, first method is for developing cubes, prism, and cylinder. Now it is radial line development. See the difference? That is parallel, and here it is radial line development. Okay, I'll tell you where it is used and what is the meaning of it. Okay, radial line development used for developing pyramids and cones, in which the apex, here all the pyramids and cones will have one apex and one bottom base. Okay, so the apex is taken as center, and the true length of the slant edge or generators as radius for its development. It's an explanation part. Okay, so apex is taken as center, and the true length of the slant edge or generators, okay, is taken as a radius for its development. And this is used for developing pyramid and cone roll out into isosceles triangles and sectors of a circle called radial line development. So you have to remember 2 methods: parallel line method, radial line method. Next slide, ma'am. Yeah, here you can see the diagrammatic view of development of a pyramid and development of a cone. Okay, so left side it is a development of a square pyramid. Right side it is a development of a cone. Okay, so if you see, you can see the difference. Okay, here in left side pyramid, if you develop, it is a triangular face, apex at the top, base at the bottom. In between, we call it as FACES, faces. Okay, lateral surfaces. They are called as lateral surfaces. Development of lateral surfaces. Right side, if you come to cone, okay, it is just a sector, a simple sector. If you develop a cone, it is a simple sector, okay, with the bottom base. Next slide, ma'am. Yeah, so first definition is over. Second, why we study about it, why we should have knowledge about development of surfaces. Third is applications. Then fourth is what are the methods, radial line method and parallel line method. Now some example problems I'm going to tell you stepwise. Okay, draw the development of a lateral surfaces of a right square prism. Sometimes we use the word right, regular. Okay, the meaning is it is placed without any inclination. It is resting on HP. Okay, that is horizontal plane without any inclination. That is the meaning of why we use right square prism of edge of base 30 mm and axis length 50 mm. Okay, so next slide, ma'am. Yes, in the exam, this is how the way you have to present this. This is how you have to present. You have to draw. Okay, development of a square prism. Step number 1. Okay, I'm telling you stepwise. Step number 1, left hand side, you have to draw the projection of the solid first. Okay, projection of a solid first. That is, the square prism is resting on HP. If it is resting on HP, here we follow first angle projection. If you are following first angle projection, top view in the horizontal plane, front view in the vertical vertical plane. So when the prism is resting, square prism is resting on HP, the true shape top view will be in the HP. Okay, top view will be the HP, and rectangular faces, the lateral surface we are going to develop, no, that will be captured in the vertical plane. So step number 1, it is compulsory for you to draw the projection of solids. Okay, so given side is 30. So first draw 30 by 30 square top view and give namings A, B, C, D. Okay, A, B, C, D to the corners. You have to give namings and you have to show the dimension line, and you have to write the dimension 30. Don't write mm there. At last, you can write all dimensions or in mm. So complete the top view first. Okay, and if you can see in the PPT, that is brackets. Okay, the meaning of bracket is there is a base, that is one more base is there, but it is not visible in the top view. So invisible corners are in the brackets. Okay, that's the meaning of names given in brackets. ABCD visible, it will be directly written as ABCD. Invisible in bracket. So complete the top view first. Next, project it upwards. Then what is the axis height given? 50. So complete the rectangle 50. Okay. So first draw the projection of solid. Give the namings. Show the dimension. Write top view, front view. So first part of your development portion is over. Second, stretching out the line. That is, you have to stretch out the lines. Okay, that is top base line you have to stretch out. Bottom base line you have to stretch out. I repeat, you are going to draw the development in the front view. That is in the vertical plane. Okay, so extend the line. I repeat, you have to extend the line. Draw the parallel line from the top base, from the bottom base. Step 2 is, and leave some distance, any distance. Okay, it is not mentioned. You can leave some distance and give the point name as A1. Okay, give the point name as A1. Take in the compass what is the side given as a radius. So 30 mm is the given radius. So with A as center, A1 as center, with 40 mm as radius, locate a point B1. Similarly, with B1 as center, with radius equal to 30, locate a point C1. Then with C1 as center, locate a point D1. And all the length should be equal to 30, 30, 30. Okay. So from D1, again take 30 and locate A1. So 4 faces. Okay. 4 faces. Now what you have to do, erect the line upwards up to the stretcher, top stretch out line. Okay. So you will get A1A. So what is A1A height? That is equal to axis height. That is 50. Okay. So first you have to locate the point 1. That is A1. Measure the sides. If it is square, it is 4. If it is pentagon, 5. If it is hexagon, 6. Okay. So 6 times you have to mark and you have to erect it. Draw the perpendicular line upwards up to the stretch out line and give namings A, B, C, D, A. Okay. So you will get 4 lateral surfaces, rectangular faces. For pentagon, 5. For hexagon, 6. Okay, and you have to darken the lines. Stretch out line should be light in color, but the faces, lateral surfaces should be dark in color. So this is parallel line method, and this is the procedure you have to follow for drawing the square prism. Next slide, ma'am. Yes, second, draw the development of a complete surface of a GI. GI means galvanized iron. Okay, cylindrical drum with lid. Lid means the top base. Okay, diameter is 30 centimeter and the height is 1.6 times the diameter. Okay, 1.6 times the diameter. Take suitable scale. So in industrial purpose, the question will be like this. Okay, it won't be just direct question. it will be only indirect. Okay, the diameter is 30 and the height, it won't be given that 50 or 60 directly. It will be 1.5 times, 1.6 times height. Okay, so in industrial, how the question will be given means, this is the example. You have to take suitable scale and you have to draw it. Next slide, ma'am. Yeah, this is a development of surfaces of a cylinder. Before starting, okay, you have to calculate the circumference. Okay, that is the perimeter. Okay, what is the perimeter required? So here you have to follow in development of a cylinder. You have to follow a formula. Okay, it's nothing but you might have studied from school. Okay, so what is the circumference perimeter? That is length L is equal to pi d. Okay, that d is the diameter of the cylinder. Okay, so calculate that is the length AA. Okay, that is a stretch out. That is the lateral surfaces. So step 1, calculate the length. Okay, length of the development L, that is equal to pi d. Okay, that d is the diameter of the given cylinder. Okay, step 1. Step 2, I told you it is important to draw the projection of solids. Okay, then you have to stretch out. Okay, so draw the projection of solids, that is the cylinder top view and the cylinder front view. Okay, since it's a cylinder, the true shape is circle. Okay, or diameter is given. Take the radius, draw the circle, project it upwards, draw the front view. Okay, here you have to calculate the front view height. Axis height is not given. So 30 into 1.6 times, it is coming as 48 centimeter. Okay, so axis height also you have to calculate. Okay, in engineering, in industries, you have to calculate and you have to do it. Okay, you have to apply yourself. Okay, apply your knowledge. You have to calculate and you have to do things. Okay, so 1.6 times the diameter. Okay, so it's coming as 48 centimeter. But if you're going to draw the diagram in a small A4 sheet, okay, it is 48 centimeter. The sheet will be only 20 centimeter. So it is necessary for us to go for a scale. Okay, so here scale they are taking as 1:10. Okay, 1:10. Okay, so after taking scale, after calculating 1.6 times, after calculating the perimeter, you have to draw the development of a cylinder. Okay, so first projection of solids completed. Second, draw straight line from the top base, draw the straight line from the bottom base. Okay, just stretch out parallel line. Okay, just from top base straight line, from bottom base straight line. Okay, leave some space, locate a point. Okay, here you just take directly L is equal to pi d. No need to divide it. Okay, so complete the rectangle first. Take L is equal to pi d. Okay, the value directly take that AA1. Okay, complete the rectangle. Then what is inside lines? It is generators. Okay, if you want, you can divide the given rectangles into equal parts and you can show the generators. Otherwise, just a rectangle is sufficient for the development of a cylinder. Then lid also, there is a lid for this particular drum. So draw the top base and bottom base. It's a circle. You can choose any generator point. Okay, not the corner. You can choose any generator point and you can draw the top base and bottom base with the given diameter. So this is a procedure for the development of a cylinder. Next slide, ma'am. Yes, third problem. Now we are coming out of that parallel line developing. We are entering into radial line developing. Okay, so draw the development of the lateral surfaces of a square pyramid. Side of base 25 mm, height 50 mm, resting with its base on HP, that is horizontal plane, and the edge of the base parallel to VP. Next slide, ma'am. Yes, here we have to look for in this problem also there in our website. also. Okay, so kindly put your attention here. A few things will be new to you. Okay, so first you have to draw the projection of a square pyramid. See here in the prism, inside edges we will not join, but in pyramid it is necessary in the top view to join the inside slant edges. Okay, for pyramid alone we will be joining inside. For prism we will not join. Okay, the reason is when you view from the top, the apex and the slant edges will be visible. That's why we are joining all the slant edges inside the square. Okay, so first draw the projection of solid. Top view, it's only one base. For pyramid, only one base. True shape will be seen in the top view. So draw the square for the given dimension. Join inside for pyramid. It is very, very important. Next, project it upwards. One apex and the slant edges. Okay, so complete that right angle, that is triangle. Okay, so draw the front view and top view. Yes, after completing this radial line method, we are entering into the development. Okay, what you have to look out is, see whether the slant edge is parallel to XY line. If it is not parallel to XY line, you have to bring it parallel, then project it upwards, then join that line with apex, and that should be taken as true length. I repeat, you are joining inside you are joining all the slant heights. Okay, that slant height, if it is not parallel to XY line, you have to follow a procedure. I'll tell you that procedure. With A as center and radius OA, draw that small arc, bring up to parallel line, then project it upwards up to XY line. Okay, then give name it as O1 dash, because we use dash for front view. Okay, so give naming as O1 dash and join that O1 dash with the top O dash. That is the true length. You cannot take slant edges as a true length for the development if the slant edge is inclined. Okay, so measure the true length first. You have to measure the true length. See in the left side, O dash and O1 dash is the true length. Yes, now we are going for the development of the radial line method for a square pyramid. Now in the compass, some distance, you can take some distance. In the compass, okay, you have to take the true length as a radius. Take radius true length. Locate a point O. Okay, locate a point O. Draw a line OA that is equal to, draw a line in the scale by using scale. Draw a line OA, and that OA is equal to the true length, that is O dash and O1 dash. Okay, next, just draw a line. Forget about the inclination or anything else. Just draw a line OA, and that line should be equal to the true length. That's important. You cannot just measure any distance or you cannot draw. You have to measure the true length and you have to project it. Okay, so OA is equal to true length. Now with O as center, OA as radius, that is true length as radius, draw a arc. Draw a arc. Just draw a arc. Okay. Second thing, what is the side given? Side is 30 mm or 40 mm. What is, whichever is given, you have to adopt that. Okay. So 30 mm or 20 mm. What is given? 25 mm. Okay. So the given size, you have to take it with A as center, cut an arc in that radius. Okay. Name it as B. With B as center, cut an arc, name it as C. With C as center, cut an arc, name it as D. With D as center, cut an arc, name it as A. Now, all the A, B, C, D, A join with the apex O, capital O. I'm talking about the development. Okay. So join OA, OB, OC, OD, OA. Now it's not going to end because the reason is for for a square pyramid, for all the pyramids, the edges are straight lines. It's a sharp edges. So you have to join not only OA, we have to join AB, BC straight lines, CD and DA for completing the drawing. And all should be a thick lines, not thin lines. Okay, it should be a see, it's like an open umbrella, closed umbrella, open umbrella. If you see umbrella, the faces will not be a rectangle. It will be steel connected to the apex. It will be like the right angle. Okay, that is right angle triangle shape. Okay, so that is about development of a pyramid. Okay, next slide, ma'am. The last problem. Draw the development of the lateral surface of a cone of base diameter 48 mm and altitude. Altitude is nothing but the height. Okay, height axis height. Okay, so 55 mm. This is a given problem. Next slide, ma'am. Yeah, we have come to the last slide. Okay, development of a cone. Here also we follow radial line method. Again, here we have to follow a formula. We have to calculate the suspended angle theta. Okay, just like that we cannot develop. We are supposed to calculate the suspended angle. Okay, so for theta you have a formula here. It is 360 into R by L. Or in the textbook it will be given as d by 2 L. That is, they will give in reference with the diameter. You can calculate with reference to radius also. So theta is equal to 360 into R by L, where R is the radius of the cone and L is the true length. True length, directly you can measure the slant height. Left hand side you can see true length. They're shown true length. Directly you can measure that O dash and O1 dash. Directly you can use it. No need of any procedure to be followed because the generator is parallel to XY line. So no need to follow any new procedures. Okay, directly you can measure the slant height that can be taken as the true length. Okay, so here in the development of cone you have to follow two things. One is calculation of suspended angle theta, and the second one is the formula is 360 into R by L, where R is the radius of the cone and L is the true length. Okay, and L is the true length. Okay, and draw the projection of solid. For cone, again, the top view, the true shape is circle. So complete the top view and the front view. Now developing part, draw a line OA. OA is equal to the true length. You can measure it from the projection of solids. Draw a straight line. From there, you calculate theta value 160 or 150, 170. Okay, whatever it is, according to your problem, you have to calculate the theta value. Okay, so if it is 160, from there take 160. Again, OA, join the sector. Okay, so here no need to join A, B, B, C, C, D, because for cone the base is, if you open the base is circle. Okay, so no need to show any straight lines or anything else. Okay, it's just a circle. Inside lines, thin lines are generators. Okay, it is no need to show. If you want to show some generators, okay, you can divide it into equal parts and you can show the generators. But the development for a cone is just a sector. So three things what you have to remember is calculation of theta, formula, and it's just a sector. Okay, no need to join the base edges. Okay, development of cone. So radial line method. Next slide, ma'am. Okay, the reference book is Engineering Graphics, K. Venugopal and V. Prabhiraja, and this is our college, our university's prescribed textbook. Okay, so you can follow this textbook. Okay, and website notes you can follow. Okay, thank you, students, and any questions?
can post your questions in your chat box. Students, this is very useful section, ma'am.
Thank you
Students,
so
I
much.
hope all of you you got a good idea and knowledge how to draw in the development of surface, and it is very useful for and this semester to your university exams. So all students, please utilize this. Students, any queries, any doubts, you can post your questions in chat box. Okay. Thank you to all. Now, I like to welcome, I like to invite the Mr. Frederick sir for giving the vote of thanks.
Thank you so much. Thank you, everyone, for listening and giving me this opportunity. Thank you so much once again.
Thank you, ma'am. Yes, sir.
I'm, I'm Frederick Jnanaraj. Good afternoon to all present here. I take this privilege to deliver a vote of thanks on behalf of Dr. M.G.R. Educational and Research Institute, Chennai, from the BTech first year Faculty of Engineering and Technology. Through A.C. Shanmugam sir for all the facilities provided. We also thank our dynamic president, Mr. A.C.S. Arun Kumar, for the encouragement and permission to conduct subject lecture programs to enlighten the knowledge of us all. We thank Dr. S. Geeta Lakshmi, Vice Chancellor, Dr. G. Gopalakrishnan, Provost, Dr. C.B. Palanivelu, Registrar, Dr. D. Viswanathan, Rector, Dr. V. Cyril Raj, Joint Registrar, Academic and Administration, Dr. D.B. Jabaraj, Joint Registrar, E&S, and all the deans, HODs for participating in this program. We thank Dr. N.S. Subashri, the Dean, E&S, for the constant encouragement, motivation, and efforts to organize and conduct subject lectures and make this program another milestone to success. We thank our speaker, Dr. Thangamani Bindhu, the Associate Professor, for taking special efforts to make and create a renewed interest on engineering graphics and inspire with solutions for development of surfaces. We thank all the participants for their keen interest to upgrade their knowledge, and especially all the students from the various sections of the first year BTech. Thanks for your participation and your patience to. Thanks to all the team members, active event organizer, Mr. S. Saravanan, and all the department staff members and non-teaching staff for their support to create this subject lecture program useful to all the students learning. Thank you.
Thank you, sir. Thank you, Bindu ma'am. And thank you to all. And thank you for participant, students.